Hello and welcome to the DIY instruction video on how to build the Look Mum No Computer Eurorack Performance VCO. This is what it's going to look like when it's finished with all Look Mum No Computer's doodles on the back. It looks pretty cool, I think, and it sounds even better. But to get to that stage, we need to solder a load of things onto this PCB. Now, if you haven't already, I will refer you to all of the documents that are down below in the description. There is a written account of everything I'm going to show you, which is good to follow along with, even though I'm going to tell you everything on there. And there is also a bill of materials. That's a list of all of the components that you're going to need to turn this into this. First off, let's go through all of those components. If you're an experienced builder and you know about all these parts already, then you can skip ahead to the start of the build and you will find that in the timeline down here. The bill of materials, the list of all of the components that we're going to need, is included at the start of the build guide, so you can go through that list and tick stuff off as you do it if you like to. We're going to start off with some of the more common components, these ones probably being the most common, synth DIY, the jacks. So this is what your patch cables are going to be plugging into. The ones that we're using on our module are FunkyCon jacks, and they look just like this, and they've got the one ground leg that sticks on the outside. You need to pay attention to that later. You also need some nuts for those jacks. We like the hexagonal ones. There are various other kinds of connectors. We've got here the connectors for our IDC cable. That is the power ribbon that is going to connect from our Eurorack power supply into the module to give it power. So that will connect into here, and you'll see that this is a shrouded connector. Not all of these come with this extra bit of plastic around the side. That is so that you can't plug this bit in the wrong way. One 10 pin, so that's 2 rows of 5, and there is one 14 pin. Other connectors, we have these 15 pin female pin headers, and these are their male counterparts here, and the male counterparts will be soldered into our Arduino eventually. This is a microcontroller board. I'll show you how to do all that, and we'll be programming this also. You need 3 LEDs, 2 red and 1 green, and these are a special type. They have a flat top and they are 3mm in diameter. As well as those other LEDs, there is a segment LED display, and one of the most easy things to do is forget to take this film off, so just do that now. This is a voltage regulator. These are some of the potentiometers that we're going to be using. For those who've bought the PCB and panel kit only, it's very important that you source the B100Ks. That means that the taper is linear. That means that at 50% of the travel, it's going to be 50% of the overall resistance. Okay, and of course 2 knobs for the 2 potentiometers. And you're going to want the round shaft, 6.35mm. That is going to fit the knobs that we are going to use. But if you are using your own knobs, you've decided to use different knobs to us, then you're going to have to find out which shaft is compatible with those ones. And don't forget the washer and the nut as well. 2 more potentiometers here, but slightly different. These are tool trimmers, and exactly the same thing really, but a different kind of format. They don't have a nut. Last type of potentiometer that we're going to have here, we have the trimmers. So these are exactly the same as these really, it's just that you operate them with a screw instead of turning them with your fingers. But they also vary in resistance. We have one 10k, we have one 20k, and we have 2 100k. And of course, you're going to need the ribbon cable itself, which you can make very easily yourself actually, just by getting the ribbon cable and then getting these IDC headers, a 10-way and a 14-way, and just using a vice or something to press that onto the ribbon. One of the best things about this oscillator is that it has a rotary switch to go between the octaves, and this is the rotary switch. Note that it does have a nut and a washer, and it also needs this little brass adapter so that the shaft will index with this knob here. The only integrated circuit that we're going to be soldering onto the board is this SOIC AS3340, the oscillator chip. This is a surface mount component. You're also going to want some M3 screws so you can screw the panel into your Eurorack system. There are a few essential tools that you're going to need to build this. Of course, a soldering iron and some solder. I'm going to be doing the entirety of this build with this cheap Antax XS25, which cost me about 20 quid, so that you know that you can do this without any fancy tools. In fact, this has been designed specifically to have really good thermal reliefs around the pads, so that you don't need like super hot irons, you don't need to be adjusting your temperature and stuff. If you have a good design PCB, you don't need to do that, okay? I said it. Much more important than your soldering iron is actually the solder that you're going to be using, and I would definitely advise getting lead-free solder. You know, people will be snobby and say that leaded solder flows much easier, but it also flows into your lungs and your bloodstream and in your brain, and to me that's not worth it. So you should still do this in a well ventilated room. If you've got a fan to take away the solder fumes from you, even better. Okay, and this one I'm using, this is the 0.7mm variety with a flux core. That means that the flux, which is kind of in the middle of all of this, is going to help the solder flow onto the joints a lot better. It kind of covers it and makes sure that it doesn't get oxidized before the magic happens and it all gets stuck together. So I would definitely recommend getting yourself some decent solder like this, and you can also buy this from Thonk, because trust me, when I started out I tried all the stuff that was in the local plumbing stores. It's not the same, it doesn't work very well for electronics. Since we are going to be doing some SMD work, I would also advise getting some proper flux paste like this stuff here. There are loads of different varieties, so shop around and get something that is not too expensive, but it's going to do the job. Hopefully we'll not need it, but it's always good to have a solder sucker at hand so we can correct any mistakes, and I would recommend these ones made by Engineer, also available at Thonk. Another bit of essential gear are some side cutters like these. I quite like this variety here. Annoying little design flaw is that the cutter doesn't go all the way down, so sometimes you can put it on and you're cutting and it's the bit that you want to cut is in here. So I'm going to look for some that are a bit better than these, but these are generally okay, this type. Let me know in the comments if you've got some suggestions, but we're going to need those for cutting off the legs of the LEDs and the trimmers and things like that. And you're also going to want a pair of snipe-nosed pliers, something like this. Snipe-nosed just means it's a bit thin at the end for doing some more fiddly stuff that your fingers are a bit too fat for. Also essential is a little flat head screwdriver for adjusting the trim pots. The head shouldn't be wider than 2mm. We're going to want a multimeter for the calibration process, and it'll make your life easier if you have one of these alligator clips for one of the probes. So before we get into this, I'm going to go through some basic terms so that it will make your life easier and you'll understand what I'm talking about. This right here, this is the top of the PCB, printed circuit board, okay, and this is the bottom of the printed circuit board, and at times we're going to be soldering components into both sides, so you need to pay attention to which side we're soldering the component into, because if you put it on the wrong side, it's going to be very difficult to then take it out and put it in where it should be. You see these little holes here, these through holes that are plated around them, and they go all the way through and are plated on the other side with copper and solder. These are pads. So if I say pad, you know exactly what I'm talking about. And these are where the legs of our components go, poke through and get soldered to on the other side. And these, for example, on the trimmers, these are legs. I know some of this might seem very basic for some of you, but we might have some people who are doing this for the first time. And if you are doing this for the first time, I'd advise you to have a little look at the Adafruit Guide to Excellent Soldering that I've linked below for some advice. But don't worry, I'm going to show you exactly how to do it. And I know you got it. And at the end of it, we're going to have an awesome module just like this. Well, it's time to get to it. And the first thing that we're going to do, since nothing is soldered on the bottom of the board and we can just lie it flat, is solder on the little surface mount IC, the AS3340. That is going to go right there. Now, you might be a little bit nervous about this because it's a little component, but don't worry, it's not that difficult. And I have specifically made these pads wider to aid the hand soldering. First thing I would advise is to give that area a little clean with some isopropanol alcohol. Just to put it on a little cotton swab and rub it over there and then dry it off. Just so that if your fingers have been touching that and oils and stuff, they will get cleaned off and it's much easier to solder to. So there are many different ways of doing this. I'm going to show you the way that I think is the easiest. The first step is to take your soldering iron and put a tiny little bit of solder on this first pad here that is next to that dot that is just above it. So just rest your soldering iron on it, just flow a little bit of solder onto there until it takes onto the pad. And this is where it's easier to have a little chisel tip or a pointed bit on your soldering iron. Now pause here, because this is the most important thing to know. This has to go round the right way. And can you see there? There's a dot in the top left corner. That dot needs to align with the dot that's on the silk screen. That is pin 1, and it needs to go round this way. Okay, so next we're going to place it onto there, roughly, and it helps if you've got a pair of tweezers, because this is quite fiddly. I'm going to do it with my left hand, so I'm going to spin this around this way so that I can use my right hand to then take the soldering iron and reheat that little bit of solder that we just put on there. Of course, making sure all the time that the IC is lined up with all of the pads. Just melt the solder and let it cool again so that is being held there just by the one pin. So now you can check whether the rest of the pins are lined up with the rest of the pads, and this is good enough, how mine looks. And you know, even though mine is further over this way than it is this way, and the pads aren't exactly lined up, this is definitely good enough. And if it is a bit more out than this, you can just repeat the process that we just did, heating up that one solder joint and just nudging this over, letting it cool again. Okay, and once you're happy with that, just solder the opposite pin onto its pad. So that's definitely holding it all down, and then we can proceed to do all of them. Now I could just do this as we've been doing it, and that would work absolutely fine, to be honest with you, but I am going to use a little bit of flux just to show you that it does make it a little bit easier. So you just take your syringe like this, if you've got a syringe type flux, and just cover the pads in it. And don't be shy. Now if you get two they get bridged a bit like these here, what you can do is just wipe your soldering iron, just touch it for a second until it melts, and then pull your soldering iron away, and you see it's pulled a little bit of solder with it. And I'll just repeat that, and there you go, they are unbridged now. I've got to be honest, I'm not the biggest fan of flux. It leaves all this horrible stuff on the board. You can clean it off with isopropanol, but still doesn't look that great. Pro tip, they make this stuff, flux off. It comes with this cool head on it with a brush kind of integrated into the spray nozzle. It's worth saying though that it doesn't actually matter electrically if you clean the flux up. It just makes it look pretty, that's it. There's no actual real concrete benefit to it. And the panel's going to be over it anyway. You're not going to see it, so don't worry that much. So give it one good check over again. Make sure that none of these legs are bridged together with solder. Make sure that there's a decent amount of solder making the leg contact the pad, and you're good. You're not going to be going wrong if you've got all of that right. And the dot on the body of the IC matches where the dot is on the silk screen. Doesn't have to look exactly perfect. Mine doesn't, but it'll work. Don't be reheating those solder joints just to try and make it look pretty. You might actually damage it. But honestly, that's the fiddliest, most difficult bit done already. Now we are going to be soldering in these two 15-pin female headers for the Arduino. You can see on the silk screen here, we have something that looks exactly like an Arduino, complete with the USB plug right there. But we'll worry about that thing later. We just need the female headers, which go in these two positions here and here. You can see on the silk screen on the bottom of the PCB. Very important that these get put on the bottom. So yeah, push them in there and then solder them on the other side. Now don't be tempted to touch the solder to the actual soldering iron to get it started melting. Touch the solder to the pin and the pad. Only once those are hot enough will you get a decent solder joint. If you're doing it the other way, I'll demonstrate. You'll not heat it up enough, you flow a load of solder on there, and then look at that. So you'll see there, the solder was too cold. It didn't really stick, or the surface tension didn't really suck it around the pad. And as I brought the soldering iron away, it just came with the soldering iron. So that was the hot bit. So if you do that by accident, it's not a big deal. There you go, there's a good example. And it's especially prone to do it on these pen headers because there's a big bit of metal inside them that is acting as a heat sink. All you need to do is just add a little bit more sort of flux in there with your new solder. Melt a little bit of new solder in there. Pull away a bit of the old solder with the soldering iron. Clean your soldering iron tip. And eventually you'll get it to a place where it's looking pretty. Takes a little bit of time. Just keep reheating it. I've bridged it over, but it's no big deal. None of this is a big deal. Just take your time. Might even use your solder sucker at this point, I think. There you go. And just touch up that joint a little bit. Do heat these up enough for the actual pin and pad to be melting your solder. That is the secret. So we're going to move on next to the 10-pin power and the 14-pin link shrouded headers, and those get soldered on the bottom of the board. Remember this. Now, as I was saying when we were looking at these earlier, there is a notch in these shrouded headers. That's so when the IDC cable plugs into it, it's orientated the correct way. So this needs to be soldered in the correct way, and the notch on here should be oriented with the notch on the silkscreen symbol. So just make sure they're facing the same way. Put the pins into the pads, push it down so it's all the way seated on the PCB, and then we can turn it over and we can solder these in. Best though to put both of these in so the PCB is going to be flat and even. When we turn it over, it can rest on there and make it easier for us. Best to solder these coming from the outside with your soldering iron so that when you move on to the other row, you're not accidentally reheating solder joints on the other side, if you see what I mean. You'll understand once you do it. Just hold the soldering iron to the pin and the pad, flow a bit of solder in there, and then pull it away, and it will make a lovely little shiny solder joint. And you'll get a feel for how much solder you're going to need to flow in there. You just get the knack after a while. Checking that you got good solder joints all the time. If you don't, just heat it up again. Flow a bit more solder in there if you need a bit more. Or take the soldering iron away and pull a bit of the solder with it if you put too much into it. turn it around, and we could do the other side. I prefer to unreel little bits of solder as I go and just hold the actual soldering reel in my hand, and I can feed in the solder like that instead of cutting little bits off or having it spooling out of a reel holder or something. You can get much better control if you're holding just a little bit of solder and you got this clutched in your hand, and you're not wasting loads of solder as well and getting little nubs that are too short to solder with. And I'm resting my forearms and my wrist here on my soldering hand on the edge of the table, so I'm not floating around, got loads of control. And at every stage, be checking your solder joints, make sure they all look good. If you're unsure what they should look like, look at the Adafruit Guide to Excellent Soldering that's linked below. Also making sure that none of the pins are bridged with solder, and especially this one down here, because this will be more difficult to access once we put the jacks on. So it should look like this at the moment, and next we're going to tackle the regulator that goes on the top of the board. But first, we're going to want to bend these legs out to make life easier for ourselves. So what I would recommend doing is going like that with that one, go like that with that one. Then you take your pliers, grab it around about there. It's not a science, it's an art, and bend it down like that. And the same on the other side. So now the legs look more like this. And this goes in up here where it says U4, and you're going to want to make sure that the flat side on here matches the flat side on the silkscreen. That is very important. So get the legs all through the pads, push it all the way down. We need to make sure that it goes down far enough so that we can put the panel on top of it, and then we can turn it over and solder those legs in place. Very good. Now for the first time we get to do the satisfying thing of clipping the legs off with our side cutters. Excellent. So the PCB looks like this now on both sides, and what we're going to do now is place in all of the rest of the components but not solder them. The reason why is because we're going to place the panel over it first and then solder, so that all of the parts that poke through the panel, they're all aligned with the panel, and so we solder them in exactly the right position. There's no bending them slightly so they go through the hole, and we're not going to stress the solder joints. You get it? So that'll mean that the solder joints are better quality, and hopefully it'll mean that the module will last forever. So first, because they hold themselves in very well, I'm going to put in the potentiometers. Just make sure that all of the legs going through the holes, those will clip in, and then they hold themselves in, so you don't have to worry about those now. They're all 100k, so you can't get them round the wrong way. The potentiometers like these go in here, the alpha 9mm ones, and the tool trimmers, as denoted by the tool trim label, go down here. Similarly, they pop in just like that and hold themselves. Lovely. Let's put the jacks in next, and remember they have this little ground leg on the outside that points up, and you can see just around the outline of this jack here there is a pad for the ground leg, so those go in like that, and similarly they also kind of just clip in and just hold themselves, which is very handy. So do that with all of them. Put the ground leg in first, then you can see here manoeuvre in the next one, and then push it over and you can get the last one in, and there it goes. Easy peasy. Next we're going to put in the display here. First off, make sure you peel the film off, very easy to forget that, and make sure that it is orientated the right way with the decimal point at the bottom. Okay, so put that in there, put it in there, and it will hold itself. Just push it all the way down for now. Remember, we're not soldering any of these in at the moment, okay? Not soldering. Okay, let's do the LEDs. The green one goes in the middle, and the long leg is the positive leg. And you see on the silk screen, there's a little plus on the circular pad. That is where the positive leg, the long leg, goes in, okay? So the green one is in the middle, the red ones are on the outside, and the long leg goes in the circular pad with the plus next to it. Okay, very important that they go around the right way or they won't work. Trimmers next. Now you need to make sure that you've got the right one in the right place, because we have 3 different values of these trimmers. Annoyingly, it doesn't tell you on them that they're 10k or 20k or 100k. They have codes on them. So 104, that means 100k. Okay, so there are 2 of those, and you can see there's a 100k center there, and you can see the circle right there. That is where the screw goes. Must go that way round. Okay, we'll look for the other 104. That's a 103. Got a 104 there. The other 104, the other 100k is up the top here. The screw goes in that way. The 103, that is a 10k. So that's this one, the track trimmer. Make sure all the legs are going through. And then the last one, a 20k, which is 203 on the code. That goes in here for the high frequency trim adjustment. Last off, we have the rotary switch. You want to take off the washer and the nut. And do remember that you need to take your pliers and see this little tab that's on there. Snap it off. Just like that. So that that edge there is flush. Now if you look underneath here, there is one pin that is in the middle. That pin goes in the plated pad right there where the arrow points to it. Okay, so you can't get this round the wrong way if you follow that. Okay, make sure that all the pins are bent out straight. They can get a bit bent up while it's in transport, but just make sure it's straight and make your life easier trying to get it in there. And make sure that center pin is aligned right. Put it through there. Maneuver a couple of the legs. You'll get it. There we go. Perfect. And just check without tipping it up completely that the leg is through the right pad. It is correct. Fantastic. There's also the numbers around here, and you'll see underneath here you've got the 1 is where number 1 is. If you want to double, triple check that that is round the right way. And you need to make sure that none of the legs have been accidentally bent under. Make sure they're all going through their pads to the other side, because if you start soldering them down and you realise that one of them's bent under and not properly through, very hard to get it all out and redo that. Okay, so everything is in there. Just don't tip it up, because a few of the things will fall out, like the trimmers. But we're ready now to place the panel over the top of all of these. Here we go. So that goes over the potentiometers first, and then line it up with all the jacks, and it will clip on down. Now the tricky bit is getting the screws from the trimmers lined up with the panel. But if you just put it straight, lift the panel up slightly, there you go. They all naturally go in line with it, and it sinks on perfectly down. Now we can put all of the nuts on, which will hold the panel in place. Some things need a washer, so the rotary switch needs a washer, and the 2 potentiometers here need washers, but the rest are just nuts. And when you're putting them on, don't tighten them up too much. You don't need to, just hand tight, and that'll be good enough. You can actually over tighten things and damage them, so you don't want to do that. Go extra easy with this rotary switch. Make sure you're not cross-threaded, because it's a plastic thread. It's very easy to mash it up. There you go. I would advise staying away from using pliers to tighten these up, because it's very easy to scratch the panel. If you are going to use any kind of tool, use some sockets, some hex sockets. You can get long hex sockets that will go over these potentiometer shafts as well. So don't go ahead right now and just solder everything in. We're only going to solder in certain things, okay? So pay very close attention to what I tell you. Don't solder anything else in that I don't tell you to solder in, okay? Very important. So first, we're going to solder in the potentiometers here and here. With the big lugs on the potentiometers, just hold your soldering iron there for a little bit longer, because there's a lot of metal to heat up, and you can flow a load in and it will just surface tension itself around there and make a nice solder joint. And be careful with this potentiometer that is inside the female header, because it's very easy to touch your soldering iron to the plastic header and melt it, but also if you're being careful, very easy not to, so it's fine. Hold the soldering iron on, heat it up, flow a bit of solder in until the surface tension just goes bloom, and then it's done. Nice. Now we can solder in all of the jacks here, making sure that the PCB and panel are pushed right the way together. There you go, that's all good. We're going to move on to the trimmers next. Just make sure again they're all pressed down and in their holes there where the screws are poking through the panel. Don't forget the trimmer up here as well, and we can clip the legs off of those. You do all three in one go. Now we're going to solder in all of the legs here on the back of the rotary switch, making sure that the nut is on all of the way. Good, check all your solder joints as you're going along. And now we're going to move on to the display here. Now you will notice that the display is kind of loose in there. You can move up and down. What we want to do is make sure that it is pushed up right onto the back of the panel, okay? And it should hold itself up there. Just make sure that it is right there, pressed up against the back of the panel. Gently turn it over and we can solder it in place, okay? Maybe do a couple of solder joints just in opposite corners. Check that it hasn't moved, that it's in the right place, and then solder all the rest of the pins. Nice. Now we're going to do these three LEDs here, but they move up and down, and we want to make sure that they are poking through the panel, okay? So there's a slight ridge that they won't go past through the panel, so you just poke them all the way through. That's how we do it, but you can also make them flush to the panel if you like that kind of thing. Easiest way to do that, lay a piece of masking tape over it and then just nudge them to it, okay, and then solder them in place. But I like to do them like this, so they're poking all the way through. That's the Look Mum No Computer way. So make sure they're poking all the way through, turn them over and solder them in place. Again, you might want to just do one leg of each, check it's right, and then do the other. If you've got it right, all of the long legs will be orientated to the uppermost edge of the board. Perfect, so let's clip those leads off. Right, so now we need to program this Arduino, and to do that you are going to need the Arduino program, which you can download off the Arduino website, or there's a link down below. And you're also going to need the code to upload via that program, which is linked down below, and you can download that as well. And it goes without saying that you are going to need a computer and a USB cable to plug into this bit right there. So once you plug this in, one of the LEDs should light up, and if it doesn't, try another cable, because some of them are power only and don't actually carry data. So open the Arduino program on your computer and then open the code that you've downloaded into it, and just click the upload arrow button. You should see some of the LEDs blinking on the Arduino itself. That means it's doing its magic stuff. If it doesn't work automatically, then you might need to go back and do a couple of the settings in the program. So select the correct board, so go to Tools and Board, and then find your Arduino Nano. You can set the processor on that Nano, so still in Tools, go to Processor and select 80 Mega 328P, or 80 Mega 328P with old bootlegger in parentheses. You can also set the output port from your computer, so go to Tools, Port, just pick the one that appeared after you plugged in the Nano. And if there's no port, you might need a CH340 driver. So Google that and there'll be loads of information to help you. Solder in the two 15-pin male headers to this. The best way though, I suggest, is to put the long legs into the female headers that we soldered in before, like so, just like that, and the other one here, all the way down. Then put the Arduino onto that, making sure it's the right way, so this should be facing up with the USB aligned with the USB symbol on the silk screen. That goes over those pins like that, and then just solder it in place. It's the easiest way. Maybe do opposing corners again, like so. And best to solder this with your soldering iron positioned on the outside edge. That way, when you get up close to the SMD chips and stuff up this way, it's much less likely that you'll accidentally hit them with your soldering iron, desolder stuff, make solder bridges and stuff. If you're right-handed, always just turn it around to suit the easiest way for you. Don't struggle by doing things upside down. Turn the work around. Okay, so right now should be looking like this. Very nice, orderly and clean. All that's left to do is to put the knobs on and you're done. So to put the big knob onto the rotary switch, you're going to need this brass pot adapter here, and loosen the grub screw so that it is clear of the inside, with the knob pointing towards the 9 o'clock direction. Tighten this up. Need to get it fairly tight so that it grips. Similarly with the two smaller knobs, loosen the grub screw so that it's about flush with the outside. That'll mean that the inside will not be impeding it going down on the shaft of the potentiometer. Make sure first that the potentiometers are turned all the way down. If you go and put them on, so they're about in that position there, put your thumb on the top and tighten it up nice and tight. And there you go. Should hopefully go around to the equal position on the other side. Well, hey, well done. So we are nearly there. It should look a bit like this at the moment. So look from the side. Pretty good. We're going to move on now to the calibration. So let's talk about the ribbon cable so we can power the module on and test it. On one end, you'll see a 14-pin connector, and you'll see here there's a little triangle there on the plastic. That denotes minus 12 volts. Okay, so the minus 12 volts gets connected into these pins on this side of the connector. Okay, so even if you have a rainbow ribbon cable like this, not a normal one that's normally grey and has a red cable on one side, you can still tell which side goes to minus 12 volts because of the little triangle on the IDC connector. You can see one there. This is how a more standard ribbon cable looks. It's grey with a red strand on one side, and that red strand denotes the minus 12. Okay, so it has to be plugged in the right way into your power supply and into the module. To also aid you, we have shrouded headers here, so you can see that the connector indexes with that only when it's around the right way. And on the PCB there is a silk screen that says red, denoting the red side of the cable. Okay, It's just important to get it round the right way. Now, all of the Look Mum No Computer modules are reverse polarity protected. So it's not the end of the world, but this is just good practice. I want to get you into the right way of doing things, because some modules are not reverse polarity protected and it might cost you, and that'll be really sad. So plug the other end into your power supply and we can get playing. And we can perform some basic checks on it also now to see if there's any big major issues, because you should be able to, for the first time, get some sound out of it. Very exciting. So for this part, you are going to need a voltmeter and also a 1 volt per octave signal source. In this case, I've got a Korg SQ1, slightly broken actually, but it will do the trick. Alright, so I'm going to plug my speaker into this square wave output, and you can hear there's a square wave, and you shouldn't expect it to be in tune when you do the octaves, but it should generally go up in pitch this way and down in pitch this way. Same with this one, and you should be able to change the pulse width manually with this one. So yeah, that's pretty good. Test the ramp output and the triangle output. Very nice. We can also take a signal from our CV source and plug that into the CV input and see if that makes any difference. That's it. You shouldn't expect it to be in tune because we haven't calibrated it yet, but it should have an effect of some type. You can test the other voltage control inputs. Pulse width. Need the pulse width attenuator all the way up. There you go. You can hear that there. You can plug another oscillator into the sync input and test that, and the frequency modulation as well. And you can also test this attenuator here by sending some CV into the lower CV input and twiddle it. You can see the tuner's doing its thing and all of the lights are turning on and off. So if it's not working at this point, I refer you to the troubleshooting section in the build guide. It's normally something really simple, so don't worry yourself too much. Most of the time it's just that you've forgotten to do a solder joint, something as simple as that, or there's one solder joint that's not quite up to quality. So just look for any that look a bit dodgy, refer to that Adafruit guide to excellent soldering down below, and just retouch, reflow any that look a bit dodgy. Beyond that, the next culprit is normally a part that has been put in the wrong way round. There's a few different parts in our build that can be put in the wrong way round. That IC at the start, the LEDs, they need to be the right way round. The trimmers need to be the right way around, although that will be fairly obvious once you put the panel on if you've got them wrong. The Arduino on the back here needs to be orientated this way. The ribbon cable, of course, needs to be plugged in the right way. The LED screen also needs to be in the right way with the dot pointing downwards. And the rotary switch needed to be in the right way with the one pin in the middle coming through the plated pad. If the tuner isn't working, try re-uploading the code. Also, it sounds really stupid, but is your modular power supply turned on? If you're tired and you've been doing this build late at night, simple little things like that can trip you up. It seems that we have a fully functioning module here. Just needs to be calibrated now so that we can play in tune with a 1 volt per octave CV controller. To do that, you're going to need a multimeter of some description, and I would advise that for the negative lead, instead of using a probe that looks like this, if you have a clippy lead like this, that would be better. It's good to leave this plugged in for a little bit just to warm up and stabilise before we do the calibration process. I doubt you have exactly the same kind of voltmeter as I do, but universally they'll have a DC volts measuring capability, and so we can see V for volts, and we can see this symbol here, which is the straight line with a dashed line underneath. That's DC, direct current. So we'll turn it to that. And then the common probe here needs to be connected to ground. So we've got a reference for the voltage, and you can find ground on the module because all of the external metal bits of these jacks here, they're all connected to ground. So you can go ahead, if you've got a clip like this, and just clip it onto here, or you can take a patch cable and put it into any of them, and then just connect the clip to the sleeve bit of the patch cable. This is the tip. You can see here there's a little separation between them, and this is the sleeve. So the bottommost bit is connected to there. That's ground. If you don't have a clip, maybe just to make life easier for yourself, so you don't have to juggle things, you could do exactly the same as this, but maybe just like tape it on so that it's connecting the metal together, but you don't have to actually hold it on your hand. Then you're free to do other stuff. So then we're going to be measuring with our other probe, and the point that we're going to be measuring on the back is right here. You see there's a pad here with nothing soldered into it. That is just solely a test point for you to put your multimeter probe onto. And you can see on the silk screen here, there's a 4 volts with an arrow pointing towards it. And we're going to be adjusting one of the trimmers on the front panel so that this point in the circuit measures 4 volts. So you need to have a screwdriver in one hand, your probe in the other hand. If you touch the probe to the test point and then hold the module like that, you see that? So I've got it gripped in my fingers here, touch to the test point, and then you can turn it around and with your other hand on the front adjust the trimmer. So we're adjusting this reference trimmer up the top, and we can see on our voltmeter that we're at 1.8 volts. So I need to go clockwise up to turn that up. This, by the way, is setting the voltage across the voltage divider, which is switched by this rotary switch here doing the octaves. That's what this setting is doing. So we just need to go to 4 volts and get there. Get as close as you can. Spend a little bit of time. Let's just get it bang on there. There we go, bang on 4. If it's going between, 3.99 and 4.01, it doesn't matter. It won't make much difference at all. Now you can turn off your multimeter, and for the next section of the calibration process, we're going to be adjusting the tracking trimmer, the one in the middle here. You might want to plug the oscillator into a speaker while you do this so you can hear what's happening with the tuning as well as looking on here. But I'm going to just do it without the speaker just because it's easier for you to hear me give you the instructions that way. So I want you to plug your 1 volt per octave source into the CV voltage control input, and then using this pot here, set the oscillator so that it is exactly on a note. It doesn't matter what note, just as long as the green LED is on. Then I want you to go up 1 octave, 1 volt on your CV controller. Just go up 1 octave and it should be exactly the same note. And if it's not, it's going to tell us whether the interval is too flat, which is too narrow, or too sharp, which is too wide. Okay, so go up the octave and we are on an A sharp. When the decimal point comes on, that means that the note is sharp. So the interval in our octave is too big at the moment. So we need to shrink that by turning the tracking scaling trimmer down. Okay, so turn it down a bit. We're going to feel this out and repeat this process. So just do a little bit for now, about 1 turn or so. Then go back down the octave again, set it exactly on a note. So we'll go to the A again and then go up the octave. And now we're still sharp on the A because this red LED on the right is on, but not as far. We're not actually showing an A sharp on the tuner display. So we've done the right thing, gone in the right direction, but we need to keep going down with the tracking trimmer, decreasing that interval again. But you'll notice that when you go down the octave on your CV controller, the note has also changed down here, so it's not an A down the octave now. That's because the tracking trim also changes the overall pitch of the module. So every time we refine this, every time we adjust the tracking trim, just take it down the octave and adjust it back onto the A or whatever note you've decided to use, and then do it again. And there we go. Look at that. After adjusting it twice, we're bang on an A up the octave. Okay, but there's only just one octave, so you're going to want to try higher octaves and then repeat exactly the same process, and that will refine it even further. And don't worry too much about this tuner. Electronic tuners are very sensitive. If it's like jumping a little bit, that's okay. Listen to it with your ears. Your ears are the real test, okay? If it sounds musical, it is musical, okay? So don't rely on this thing. This thing is not gospel. Listen to it with your ears. It's a musical instrument. So there's something inherent in the oscillator chip that this uses that means that you have to do some extra compensation at higher pitches to ensure accurate tracking. So in the higher octaves, when you're doing this, you can use the high frequency trim to add a little bit of extra compensation at those high frequency ranges to bring the tracking in line with the tuning. That works exactly the same way as the tracking trim, just only has an effect in the highest of the octaves. Cool, so now that we've got the tracking right, we can set the center position of this pot here so that it's on a note that we want. There's no hard and fast rules of which note that should be, perhaps a C, but maybe just do it in line with the other oscillators in your rack so that they're all in tune with each other, or not, whatever you want to. But if you adjust this center trimmer here and make sure that the arrow is pointing to the middle position here, then you can adjust it to whatever note you want. I'm going to put it on a C, and that means that we can go down to a G sharp there and up to a G sharp that way, minus and plus 6 semitones. Right, so let's play a little sequence on it and see what it sounds like. Pretty good. So thank you very much for buying one of these. I hope you enjoyed building it, and I hope you enjoy using it as well. And if you want to check out other items in the Look Mum No Computer range, you can check those out on his website. And if you want to check out things in the hack range, then you can check out my YouTube channel or the shop or the Instagram page. And there's loads of good stuff there as well. Toodly do. Thank you very much. Happy bleeping.